Pretty good afternoon, everybody. Welcome to CS 5170 Advanced Natural Language Processing. It's a pleasure to introduce our today's guest speaker, Aman Chadha, a true legend in generative AI and reinforcement learning. Aman leads Gemini post-training at Google DeepMind, driving reinforcement learning, supervised fine-tuning, and evaluating the evaluation for new use cases. Before this, he led generative AI teams at Apple, shaping Apple Intelligence, and at AWS, building agentic pipelines. Earlier roles include Amazon Alexa AI, Apple's Mind Team, NVIDIA, and Qualcomm. He also advises academic research on large language models, hallucination detection, and multi-model AI with award-winning papers at EM, NLP, and IEEE TPS, and work featured in Washington Post, MIT Technology Review, and Nature. Please join me in welcoming Aman.
Thank you so much for the warm welcome, Fatima. And yeah, I'm so excited to get an opportunity here to connect with your class today and talk about agentic skills, which is very important and upcoming paradigm in the whole agentic space and broadly in generative AI. We were seeing this transition from you know single shot LLM based flows, which was what we had up until early last year or so. And now most of the pipelines, most of the systems that we work with in the industry are, more or less agentic, and having different agents coordinate amongst themselves and get a particular task done, work towards a goal, is how we're structuring most of our generative AI deployments. So, and building skills for these agents is a big piece. To ensure reusability of, different, features and, parts of the pipeline. So I'm glad to be covering a topic that will hopefully be helpful to your students as they get started with their generative AI journey, either in the industry or academia. Um, so yeah, the slide that I've got here gives an overview of the entire pipeline, what we're going to be covering today. We're going to go over the agenda now, and we're going to cover topics in clockwise fashion. So we're going to start off with the background first. So if you look at the bubbles on the right side going clockwise, the bubble at the top talks about the first aspect that we'll cover. So that's going to be the background in terms of agents. And I know you guys had I heard you had a fantastic class a couple of days ago covering agents and agentic design patterns and other related topics are centered around agents. So I will cover the background in a little bit of detail. I won't go too deep into defining agents and talking a whole lot about agents, but I do want to center today's conversation around skills, building skills for agents. So, we'll cover the background in some detail and then we'll move over directly to the motivation behind why we need skills in the first place, right? Why can't we carry on with what we're doing right now? What's stopping us from continuing to leverage the great, infrastructure that we've got in the generative AI space, the research that we have, and what we're already using to build together these production grade flows for agents. So that's going to be the motivation that we'll cover for agentic skills. And then we're going to move over to the next bubble in clockwise fashion. So that's going to be talking about what an agent skill is and what are the key core concepts that are needed to set up an agentic skill, right? So that's going to be the next slide. And then we'll talk about why these skills exist and what are the key areas they tackle that regular, single shot, LLM flows or even agentic flows powered by prompts, why aren't they necessarily enough, right? So we'll touch upon some of the key unique selling points of agentic skills. And then we're going to move over to something called as progressive disclosure, which is the entire basis of how skills are utilized and leveraged and adopted in this flow. So in generative AI flows, so progressive disclosure is what powers skills, and we'll touch upon what it is and how do you enable it, at runtime with an LLM. We'll also speak about how do you keep, context efficiency in mind as you structure these agentic flows and how skills help in that regard. And then we'll move over to setting up a skill. We're gonna basically talk about what it takes to build a skill. Now that we've covered a whole lot of the pieces around, the what and the why, now and we're gonna start proceeding with the how, which is how do you come up with the skill, right? What does the skill look like? What's the structure? What's the anatomy of a skill? And then we'll move over to how do you trigger a particular skill at runtime? How does a system, a generative AI system, decide what skill to use at runtime, and how does it fetch a particular skill that's relevant to the input query, and how does it activate that skill? That's going to be next. And then we're going to go over what it takes to write a good skill. What are some best practices? So we'll cover that. And then we'll talk about evaluating and iterating on skills to make them better. How do you carry out that iteration process based on what you're seeing during the evaluation process? Are you seeing any gaps? And if so, how do you polish the skill further? And lastly, we'll conclude the talk for today, talking about how do you go deep into any of these areas. How do you learn more? So I've put together a list of key papers that you guys can go through if you're interested in delving deep into the area of agents broadly, and specifically the area of agentic skills, and primers that I've written to help develop a background in not just broadly the field of agents, but also other related fields, allied fields in generative AI, including LLMs and RAG and preference optimization, RL, a lot of different related concepts. But I've included a set of links to a bunch of different primers if you'd like to go deep into any of these areas. So that's how we're going to structure today's talk. So we've got a lot to cover, as you guys can see. So let's dive deep and let's proceed with the first part, which is the background, which talks about what an agent is and what the core capabilities of an agent are. So the idea behind an agent, and like I said, I know you guys have had a background from a couple of days ago from your last lecture. So I won't dive too deep into this, but as you probably have heard, the idea behind an agent is to act sequentially, with a particular learned policy and not just generate text, right? And the way you do that is by having an LLM, be positioned right at the center of this particular pipeline. So if you look at the diagram on the right, the core of the system is an LLM trying to, take in the user input and figure out what to do with that particular flow and take relevant action based on what's being requested from the user. And as part of this journey, utilizing a whole bunch of different components around it, right? For example, memory, is a key piece of the whole pipeline because you cannot take effective action until you understand, how the kind of context that exists in terms of the particular conversation the user is having with the model, for example. So prior interactions with the model could be one thing in terms of short-term memory, where we utilize the context of the model to figure out what's most relevant to this particular query that's posed in to the model in this particular turn of the conversation. So that short-term memory is important. But the long-term memory aspect is also yet another thing. So memory typically is of two types, short-term and long-term, right? And the long-term portion of the story is typically implemented as a vector database. And that gives the model, the core, agentic core, access to information that could be dynamic in nature. It could be information, data that it's scraped from, any set of local files. It could be information from the web. But once you put together a vector database, the agentic core can retrieve what's most relevant at runtime from this database to understand the broader context that's most relevant to this particular query, along with the prior interactions that the user has had with this particular agent, which is part of the short-term memory. So putting all of the both of these aspects together, the short-term and the long-term aspects, that's the memory module that feeds in relevant information to the agentic core, so it can leverage its experience and the data that's stored in a vector database. And the other key piece to an agentic system is tool calling capability, which is very commonly seen because if you think about it, for an LLM to interface with the external world, a big chunk of that interfacing is centered around APIs and tools, because that's the way software development works. You can expose features from tooling around the model. For it could be your inbox, your mail inbox versus could be your chats, for example, could be any kind of tool, Slack integration, integrating with the browser. All of this can be done. The model, would basically, the agent would have access to the external world via tooling, right? And tool calling capability is obviously, which is why it's one of the biggest pieces of what defines a good agent, right? And an agent that's effective. So that's the other block that you'll see here, the tools. And then, the planning module is yet another piece which, helps come up with an idea of how to execute on a particular goal that the user's given to the agent, right? So once the agent receives the overall the request from the user, how do you decompose that particular request into various substeps, where each substep builds towards that overall goal one by one incrementally, right? Building off of the prior substep, right? So that is the whole planning process, which is yet another, that could be yet another agent, right, whose job is just to take in the input query and come up with a step-by-step plan. But memory module and tools are obviously external. They're not, generative models, unlike the planning module. But the idea behind this end-to-end system with all of these different components is to have an LLM go beyond generating, output to taking action, right? And that's mostly enabled via the tool calling capability, but made more effective by the memory module and planning, which are the other two components of the pipeline. So this is typically what how an agent is set up. There's a whole bunch of different frameworks, whether it's LangChain, LangSmith, and LangGraph on the open source side to every vendor right now has its own, whether it's OpenAI or Google or, Anthropic, any of these frontier labs, all of them have their own, frameworks as well to set up agents. So there's, it's pretty easy to come up with an agentic flow now, assuming you have a lot of these key pieces figured out. But this is a definition of what it takes to build an agent and what makes an agent good at what it does by having, these components, memory and planning and tool calling baked into the whole system. All right. Now, with that out of the way, that was background for us to understand and get on the same page with what agents are. The next step is to basically, figure out why we need agent skills, right? We can build agents just fine. Like I mentioned, there's so many different frameworks and libraries available, whether it's, open source or proprietary frameworks. It's, you can structure a particular problem statement pretty easily as a multi-agent system now. So if things have been democratized so much, why do we need agentic skills, right? So let's touch upon that aspect here. So this slide basically motivates the whole idea behind agentic skills. And the idea is that your models out of the box are pretty powerful, but as far as task-specific workflows are concerned, and having access to up-to-date knowledge, those are key areas where your models typically need more context. They typically need more than the amount of capability they have out of the box, right? And what I mean by that is, think of, if you're a legal expert, or somebody in medicine, for example, could be somebody in finance, any of these specialized domains, and you're looking to build a system that could serve as a great co-pilot or a co-assistant for the entire for some of the day-to-day work that you do need some task specific workflows here. A legal expert, for example, has to do, a lot of document review, and, even draft documents in a lot of cases to, in accordance with judicial policies, for example. So a lot of those task specific workflows need a context that, need to be offered to the model, to the LLM under the hood, to for it to know that what you're looking to do, and what are some do's and don'ts, what are some key ideas that it needs to, take into account and consider before it's able to come up with, an end-to-end workflow to solve that particular problem. And not just that, that's just the workflow piece, but also up-to-date procedural knowledge. That's another dimension where, again, taking the same example of a legal expert trying to build a workflow to make their lives easier and to serve as an assistant for them. You also need up-to-date knowledge in the sense that, there could be new legal cases and happenings and outcomes, coming out of the judicial system. How do you have a model know what's the latest, set of your precedents that have been set up, for example, in legal cases and in judicial settings. So a lot of that has to be retrieved at runtime for the model to understand some of that context, right? So this is the knowledge gap that drives the idea of agentic skills, where you got a static model out of the box which has a lot of good knowledge and, idea about concepts, stored in its parametric weights. But how do you have it evolve beyond that and go beyond that to, coming up with, end-to-end workflows that are grounded in data, grounded in knowledge, and where each of these different, agents in that particular workflow that tackle, key pieces that let it work towards that entire goal of what the workflow is looking to do. How do you have them, call the relevant APIs, call the fetch the relevant information at runtime? This is why we need a skill to package all of this information together, all of this domain knowledge together for each of these agents, and then at runtime be able to, figure out what's most relevant as a skill that needs to be fetched and run, for each of these agents, so they can get to their sub goal in the best manner possible, in the most performant manner possible, and overall deliver an end result, which is basically the cumulative effect of all of these agents working hand in hand in unison and delivering a great end result, right? So their capability is literally, to be able to extend and stretch their capabilities to the next level for these agents. Agentic skills are pretty useful, and that's exactly the problem that they solve. So, like I said, knowledge gap is a big area, a big deficiency with current static off-the-shelf models that do not have access to any external information or tool calling capability. They're also missing a lot of the procedural expertise, right? Like I said, in the example of a legal agent, you'll need the various sub agents that get spawned as part of the process to utilize the domain knowledge that the human in the loop, the legal expert, can offer, and structure their specific roles. So that's the procedural expertise here. And the other challenge is, managing context, right? Context windows are limited in size, even though we're seeing them grow, significantly from the early days where we had a couple of thousand tokens at the input as context. At this point, 1 million tokens in context is being seen with a lot of providers. And in fact, recent progress has been stretching this number to tens of millions at this point. Early, like a 10 million context window is being looked into already in research with a couple of vendors. And there's also open source models at this point where we're seeing them stretch the context windows to a million and further beyond as well. So a lot of this is now readily available. But the challenge is that as you run industry grade workflows, it is very easy to actually hit these kinds of numbers too, because and pack your whole context window. Because if you think about it, running industry grade workflow on billions of data points, so where every agent is looking through all of this data that's stored in a vector database, trying to fetch relevant information. Now think of that agent multiplied by so many different agents, hundreds of agents that are spawned at runtime dynamically by the whole system. Um, all of that leads to, can lead to an overflow of context if there's just one agent performing the entire end-to-end task, right? So if you've got one LLM that you interact with, and in the same session, as how you and I would do it, right? If you were to interact with, say, Gemini or ChatGPT or Claude, for example, go to the web app and query them, right? And if you just carry on in the same session, especially if you got large, you know, files being uploaded, could be even code, that's uploaded a whole repository where you're looking to figure out something as part of that repository, and then asking it questions that are centered around the code. All of this is being packed into the same context window, right? So that's no good way to scale, right? So the context overload problem is yet another challenge, which in some ways mandates that we explore agentic pipelines and thereby spawn multiple different instances of the same model, or could even be different LLMs, but spread the context along different agents and not bottleneck one model with just one piece of with one context window, right? So that's another big challenge, which lends itself very well to a multi-agentic system and this is where agent skills again come in to structure that the whole multi-agentic system. The other thing is that in terms of performance, we also see multi-agent systems do better than single-agent systems in generally in cases, but it all depends on the type of problem statement. If you have a problem statement that's inherently serial in nature, where you do need to carry out a whole bunch of tasks one after the other, and there's no parallel dependencies. You could have the coordination overhead between the agents bottleneck you, where the latency, for example, of the old end-to-end system starts to eat into the whole pipeline, and you don't get a system that's smooth and fluid at the end of the day. Because with a single model trying to do a whole bunch of different things, you will likely see better latency because they don't have to do coordination amongst multiple agents. But the challenge here is that with agentic systems we do typically see better performance, because if you make a model do one subtask and just have it do just that, we typically see good levels of performance in those cases, compared to having a model take care of a very a goal that has a whole bunch of different aspects. So that is definitely a big challenge, which again pushes us towards multi-agentic systems where having a whole overall task be planned and distributed across different agents does lead to better performance. So that's the reasoning action link aspect that I've mentioned here on the slide. So these are the key, three or four different aspects that have pushed us going from single shot LLM based workflows, which were the case up until a year and a half ago or so, early last year, I'd say. And now everything is agentic, just because of some of these challenges that we've seen, whether it's a knowledge gap aspect or it's the procedural expertise that needs to be baked into the agentic flow, or its context window limits, and better performance as a result of slicing and dicing the overall task at hand. Um, and the core idea and the insight here is that the bottleneck here is not capability, because at the end of the day, it's the same model that you can run that's powering all of these agents under the hood, right? In certain flows, we do see that different models, play the roles of different agents. That happens. But theoretically, you could have any of these flows being run by the exact same model, which is in fact the common case. That but so the challenge is in capability, because at the end of the day, it is the same model that's serving all of these agents. But the idea is that you want to be able to bake in this procedural knowledge in a structured manner, and that's where agentic flows come in, where not just the structure is something that we benefit from, but also the ability to be able to manage context windows effectively and yield better performance at the end of the day. And being able to bake in the specific expertise that's needed for each agent, and come up with detailed prompts that talk about the roles of these agents and the do's and don'ts that would make them effective at their own task. So this is the reasoning behind why we need multi-agent systems and the kind of role that agent skills play to enable that transition from single shot agents. All right. Now, with that out of the way, we're going to start talking about what these agentic skills are, right? And what are some key concepts that enable the implementation of these skills. So if there's no formal definition per se, there's no single paper that's introduced the idea of agent skills. We are seeing papers come up now that talk about using skills in different contexts, and but I've tried to put together a definition here, which is that a portable package is of some procedural knowledge that enables agents to carry out their specific task, subtask better than just having a simple prompt with which is basically fed into a model, and then that being instantiated as an agent. Rather than doing that, coming up with that package of the various kinds of context the particular agent could leverage at runtime, which is what I mean by procedural knowledge, and this being loaded on demand as agents are being run, right? That is what makes an agent skill. And the idea is that you know you can take a particular end-to-end workflow, so a structured workflow. There is no new model or specific tool call that needs to be added to the whole workflow. That is not the point of distinction here, but the way you structure the whole process and enable these particular agents to look for relevant skills and then load them at runtime and then leverage those skills once they are loaded to carry out that particular task. That is where an agent skill comes in, right? So in that sense, it basically encodes when, how, and in what order a particular agent should act to make sure that they get to their particular sub goal and do that better than the kind of context they had available access to earlier, right? So this particular encoding, the when, how, and in what order, is what makes an agent skill shine, right? This is what gives the model added capability, structured capability to carry out the particular sub goal well. And the way we do that is, as we'll see in the upcoming slides, we encode a particular skill in the form of a directory. That directory is what the model scans at runtime by doing API calls, because the model cannot look at files and cannot take action directly. Like I said, everything has to be via an API call. So this particular harness that we set up, you can think of, Cloud Code, for example, or Gemini CLI, for example. The way things work out in these multi-agent systems is there is a harness, that's the heart of the system, that tells it to look for, scan particular directories by making certain API calls. Could be Python code, for example, that gets run in a sandbox environment where certain files that are available are retrieved and this gets fed back into the model. That's typically the flow that we see. And as it's scanning these directories, it is looking for instructions, it's looking for scripts, it's looking for relevant assets, and we'll touch upon all of these aspects in detail in the coming slides. So don't worry about the specific aspects of what make a skill. We'll go over those in detail. But the ability to look for these aspects at runtime by scanning the file system and figuring out of a multitude of skills that are available around the model, what is most relevant for that particular agent at runtime to do its job better. That is the entire essence of what building a skill involves, right? So, and all of this has to be only activated when the agent is trying to tackle a particular task, right? Um, so it's not, the idea is that the discoverability here has to be dynamic in nature. It's on demand. You don't just set up an agent and then have it load up skills for no reason, right? That would basically imply more latency. And even though, eventually it might have a skill loaded that is relevant to what it's doing. The challenge is that you're then filling up its context window, which again takes us back to the same problem we had on the last slide. That's one of the big reasons why we need this dynamic discovery, feature, right? That skills offer. So it's important for this to be on demand. And the pros here is that, a lot of this flow is modular, it's reusable, and as we'll talk about in the upcoming slides, you can, version scales, you can make changes to them, you can add more examples to them. So it's pretty modular, right? And it's reusable because at runtime, different agents could, even load the same skill if they're trying to carry out a particular task that's related. And it's shareable, versionable, because at the end of the day, these are just files. So all of the benefits of having this structured as just files and directory that encompasses all of these files, all of those benefits come about as a result of this, the way skills are structured. And the cons here are that we obviously need to do careful design of the skills, and we'll talk about the key aspects that we really need to take into account to set up a good skill. And a lot of this also requires domain expertise, right? So you say if it's a like I mentioned earlier, a legal workflow could be a workflow in medicine, could be a workflow in finance, or any of the other specialized areas. You want to be able to scope out a particular skill. You want to understand what the role of the sub agent is, and what kind of structure would you have in the agentic system? What are the roles the different agents would play? So that scoping has to be done. Writing has to be done to put together all of this, and there also has to be enough detail around examples, for instance, that would make the particular skill more effective. And there's also challenges around evaluation, because these are very custom tailored flows, right? As you can imagine, once you set up a skill. So how do you know if the skill is doing the right thing, right? How do you know that it's being triggered right? How do you know that it's rendering the right outcome, right? In different kinds of settings and inputs. So that evaluation piece is also challenging, and we'll touch upon some of that too in the later part of the talk. So now that we have that out of the way, we're going to talk about why skills exist. And this is, the slide basically touches upon, I'm trying to reinforce the key ideas that we covered, already. So we're going to quickly cover this. But the idea is that knowledge gaps are something that are very difficult to patch otherwise if we do not set up something as a structured entity, which is an agentic skill. So, you've got these flows that are getting deployed with multiple different agents for specialized problem statements. But how do you ensure that these flows are all kept up to date, right, in the real world? So, there's going to be evolution in terms of data, in terms of practices, in terms of, guidelines that you want to offer each agent. So to be able to do that easily, it's important for us to, structure things accordingly for us to be able to make edits rather than go deep into model, code, for example. So all of this gets structured outside of the model, and like I said, it dynamically looks for aspects and tasks that are relevant. And the this basically lends itself very well to making changes and making sure that your skills evolve over time, because at the end of the day, these are just markdown files, as we'll see. So for you to be able to go in and make a change for because you saw something in your evaluation where a skill wasn't doing the right thing or wasn't getting triggered right, all of that becomes way easier. Um, And this basically lends itself very well to patch that knowledge gap and offer that procedural memory to the model, because it tells the model, when to invoke the skill, as we'll see later on in the skill structure. It tells the model how to go about tackling that particular task for which it's looking to utilize that skill. And that put together, helps it render the best result possible for the particular task that the agent is looking to execute. So in that sense, the skills, guide tool use, and they would mention defaults in cases where a tool isn't returning the right output because, say, the API isn't responding, or you're getting a timeout error, for example. How do you handle edge cases? You could also package examples of how to really leverage that skill and the kind of output to expect. How do you post process that output, for example? So all of that can be baked into a skill, and this all of this, the a good byproduct of all of this is that trial and error gets reduced, because skill essentially packages all of this wisdom, all of this procedural knowledge in one place, and this increases consistency, and it helps you, get your outputs to be more performant compared to not having skills in place. So compared to your baseline, you'll see an improvement in performance if you structure skills right. And this is all great when you have a structured workflow. Like I said, if you have a problem statement that can be sliced and diced, where you can go through a multitude of steps, one after the other, where some steps are serial, some of them can be parallel as well. Um, in those cases, it's, I think, a good idea to set up a skill. So that's where skills really come in, and ensure that you're able to streamline your entire process, and any kind of repeated procedural tasks, they can be served by the same skill again and again across different agents. So that's the entire idea behind why skills exist. And now that we understand those pieces, we're now starting to get into what enables these skills to do, do the magic that they do, right? So progressive disclosure, like I, touched upon earlier, and context efficiency, those are the key aspects. So we're going to cover those next. And what with progressive disclosure, which is the one of the key underpinning ideas behind skills, the basic idea here is that what you do is you load minimal metadata first, where you're basically giving an idea to the model about what kind of skills exist. So a model needs to know what the lay of the land is like, what its universe looks like first, right? So if when an LLM gets that understanding, it's easy for it to leverage that understanding later on as it's carrying out various tasks to invoke the right skills, because it understands, it knows that these kinds of skills exist to help with its task. So being able to make that split where you load some initial metadata for the model to understand the state of the world around it and all of the skills that are available, and then look at the next set of instructions, the full instructions, only when it's required and needed. So that conditional loading is what is termed as progressive disclosure. And so the way it works is that it's typically structured as a three-step process. The model basically, when it's initially invoked, it looks at, it does skill discovery, it looks for skills, understands the, based on the description of the skill, as we'll see, as being one of the key fields in the front matter, as we set up a particular skill. Based on that, it knows what skills are available, right? Based on just a particular field, for example, or a couple of fields, it does that initial discovery, and then at runtime it uses that to activate a particular skill, and at that point it loads the entire skill based on the relevance of the task. So these are the three key steps that power skill discovery and loading. And the good the biggest benefit here is that all of this avoids loading all of the skills up front, right? And that would, if we were to do that, it would beat the idea of having all of this work done and to create a skill, because like I touched upon in one of my first initial slides, is that the challenge with setting up, a flow as a singular LLM system, one of the biggest challenges is context window overflow. So if you were to load all of the skills up front, you would basically be loading huge prompts corresponding to each skill, and now multiply that with the number of skills you have, and all of that had to be packaged, or would have had to be packaged in the same prompt. So your basically, we term this context rot, which basically means you did not curate the context that's going in. You did no context engineering, and the problem with that is that you start flooding the model with a lot of irrelevant information that essentially avoids it, or hinders it doing its task right. Right. So you don't want to overload a model's context window as much as possible unless it's relevant information. So this avoids all of that happening, and this also, has good byproducts in terms of reducing token usage. So that way you lower your cost. And like I said, context rot is another key challenge that we see typically with these models. So that's another thing that we avoid. Um, so there is this, the selective depth aspect, right? Where it figures out, the metadata that needs to be loaded, gathers that first, and then goes next level only when you actually need the skill. And the key advantage here is that this scales to a lot of skills. It's pretty easy to scale this without overwhelming the model's context window, like I mentioned earlier. And the con here is that the design has to be done very carefully. Like I mentioned, there's certain fields that the model initially looks at, which are part of the front matter, as we'll see, where these initial fields are defined before the entirety of the whole prompt. And these fields, the success of a system like this depends totally on how well these descriptions are written, right? So you want to make sure that they are contextual. These descriptions include enough relevant detail, so the skill is not missed on, or not activated unnecessarily during runtime, right? So, but to be able to scale the system across many different skills, it's pretty easy to be able to work with limited context windows. That's another key thing that it enables. And you could have diverse tasks, and skills would scale pretty well across many diverse kinds of tasks that are being executed. So that was progressive disclosure and how we use skills to make sure that we keep our context window in check. Now we're going to talk about how do you structure a skill, and how do you create a skill, right? So this is in some ways, the heart of the entire talk today. And I've got a bunch of slides that talk about how would you come up with a good skill in the first place. So the way we do that is on the right, you'll see a figure where I've put together, a rough structure of a skill, where you create a directory that could be the name of the skill. And within that directory, you could have a markdown file, the .md file, which is skill.md. And this file basically has metadata and some instructions, right? So that is absolutely required because this is what enables discovery, right? And it could also further on beyond the skill MD file, there could also be optional supporting folders such as scripts, references, and assets. So these are the three types of folders that you typically see in skills, because what we're trying to do is that we're moving away from a single flat prompt, which is typically the case with general LLM usage as you interact with, say, a model via a web app, right? And you're in a multi-turn conversation, and you're trying to move towards a small inspectable packaged offering, right? Where this particular offering carries out a specific task. So, what you're doing together as part of this packaging is that you're combining instructions, you're combining information about executable, helper functions that you can run, you're including any reference material, and all of this is packaged as one portable unit. Um, and all of this, because it's just general files, like I mentioned earlier, can be versioned. So you can make changes to it over time and inspect changes and work together as a team, for example, which is true, most of the cases in industrial settings where you've got a team working on a particular aspect. And because of version controlling and, reviews in the form of code reviews, for example, and sharing, all of that becomes way easier just because of how this structure works out. But now diving deep into all of these different aspects, right? The different files that we talked about and the folders. The skill.md file is called more or less a control plane where it contains the entry, that's the entry point, right? Where the model basically looks at that to understand what metadata exists for routing and understanding when the skill should be invoked for execution. And then what happens is that going from that metadata from the skill MD file, then we could include instructions as well within the skill MD file. But beyond that, all of the other resources, the scripts and the references and the assets folders, each of them play a specific role in this entire journey. And the scripts folder, for example, what it does is that it puts together reusable actions where you're trying to reduce repetition, and we'll touch upon each of these three in more detail in the coming slides. But the idea is to foster reusability with the scripts folder, where it's literally a script that's being run again and again. Think of it like that, right? So you're trying to reduce the repetition amongst agentic workflows. References is yet another folder where we store detailed context. And this, I'd say, I term this secondary context, where only when a model has to carry out a particular task and run this particular skill and understand auxiliary secondary data about the skill, should it really look into docs and notes and source material. So once it needs that secondary next level understanding, the model does reference the references folder. Assets are yet another folder where we typically put together, any templates or static resources that are needed to carry out this particular task well. So these are the three key folders that you see as part of any skill. And mind you, these are optional. So in some cases, you might not see these folders at all, where it's just skill.md. That's possible. That's doable. But then the idea is that you need these three folders and files within these folders, obviously markdown files, as we'll see, because you do need some amount of reusability here, right? So scripts, for example, which is the most common folder that's seen amongst these three, you do want those executable helpers, right? Because you're trying to run code at the end of the day, and all of that reusability only becomes a part of the whole picture once model is able to look at what executable helpers are available as part of the scripts folder, right? So in this way, we basically combine all of the instructions code, which is the helper function that we just spoke about, and other secondary resources like references and assets. All of that is packaged together as a portable unit. So this is a top level overview of the structure. And then next up, we'll talk about the skill MD in a little more detail, where the core idea of the skill MD file is to separate routing metadata from the executing instructions. So that delineation or that boundary where the metadata becomes part of the discovery phase, right? That's essentially what an agentic model, right, an LLM uses at runtime to discover that a particular skill exists and what that skill does, in which conditions should it be invoked. That description field is part of that metadata. And the execution instructions are obviously separated because they're not part of discovery. They're part of, once discovery is done, once you want to run a skill is when you look at execution instructions, right? So that separation, that delineation is what skill.md enables. And the way it's done is that the front matter, within a particular YAML file, for example, or YAML is just a placeholder here. You could have a markdown file like we've seen the .md files. You could have XML files too. But the field, in general, a lot of the industrial implementations, everything centered around markdown files for now because they're very easy to write, and it has a good amount of open-ended structure too, rather than having key value pairs in a JSON file, for example, right? So, but the idea is that any kind of file at the end of the day, any kind of structured format at the end of the day has markdown, has a front matter in the very beginning where it talks about key metadata associated with that file. So Markdown has that too. YAML could have it too, and JSON can have it too. But the idea behind that front matter is that the description within that front matter, which is usually at the beginning of the file, as we'll see in the coming slides, that enables our discovery. That's where we write the metadata and store the metadata associated with that skill. So, and this gives it enough structure for indexing and looking up the particular skill and also makes it very simple for editing and evolving and improving that skill over time. So the whole idea here is to make sure that the metadata gets used for discovery and activation if the skill is relevant after discovery. And there's also the good idea around the key piece around portability. When you switch from one model to another, as long as the system prompt of the model understands that it needs to look for skills, and this is the roughly the structure, a skill.md file and such. Once all of that information is in the system prompt, you could do the same thing with any model out there. I'd say Claude was one of the, I think the probably the initial model that came up with some of these ideas, which is why you see a whole lot of Claude.md files if you look up online for skills. But the same idea can be applied to any kind of LLM. So it's not specific to a particular model because the instructions are in natural language, and being able to follow these instructions is at this point with current state of model is pretty easy. So this basically enables discovery and activation, and also lends itself very well to specifying key do's and don'ts, edge cases within that particular within the execution instructions, for example. So all of that can be encoded as part of skill MD. And what agents typically do, what an LLM model running as an agent would do at runtime is it would inspect the metadata in the front matter of the file, and we'll talk about the front matter too and how it looks. But it's basically a set of keys or values at runtime, and it's going to look at that, and based on the description within the front matter within the same skill MD file. It's going to figure out if the skill is relevant, activate it, and this basically enables it to understand if going further down beyond the front matter, looking into the execution instructions, and all of the key steps and defaults and edge cases and all of the whole procedural aspect of the skill, is that meaningful, is that relevant to the task at hand, right? So that discerning the decision making here, which is what makes an LLM an agent, is how this whole process is carried out. So this is what skill.md enables, and that's why it's the heart of the entire system, and aka also called the control plane, like I mentioned earlier. Now, I know I made a bunch of references to front matter, and some of you folks might not have a background in what a front matter, field is for any of these structured files. But don't worry about it. We've got it covered here. And honestly, it's very simple. And the idea is that in the beginning of the file and in a .md file, what you typically have are a bunch of different keys and values, much like a JSON file, for example. So you have, say, a name, a description, and these key value pairs basically drive discovery and activation of the skill. So as you'd imagine, coming up with a good name and a very nice detailed description is critical for this process to pan out, right? Because if you do not include a great description and you don't invest in coming up with great descriptions for your skills, the issue is that the success of your system is going to be limited, right? The discoverability of that skill is going to be limited. So that's one thing to keep in mind, to come up with a great description. And You could also have a name field, like I mentioned, that's typically seen. These are required fields, names and description. The name field basically offers an identifier that's just for bookkeeping to help with portability and validation. But it's a good idea to keep a verbose and a relevant name, so the model can take a look at the name as well as the description to carry out discoverability and understanding if the skill is relevant. Description is in particular the primary activation surface. That's the main key the agent is asked to look at to understand what the skill does and when it's right to invoke that particular skill. And there's a whole bunch of fields beyond this, beyond name and description, that you can include. They are all optional. Could be license, compatibility, metadata, any other aspects around the tools that are allowed to be run to support data governance and extensibility. All of that can also be included. You could also have other fields beyond this, but all of those are optional. That's more for human bookkeeping than anything else. Like I said, the model or the agent mostly relies on the description field. And basically, beyond these fields, that's where your front matter ends. And beyond these fields, you've got the body of the instruction, where you've got markdown procedures that define the workflows, the defaults of the workflow if a API call times out, for example, and any recovery strategies, for example, if you're not able to run a particular function call that you'd mentioned in this particular skill, for example. So how do you get past that, right? So all these edge cases need to all be specified. So as you'd imagine, this would be a very comprehensive set of steps, to be mentioned within the skill. And this is essentially what makes a skill, right? All of these different aspects that need to be specified. And these need to all be encoded with project-specific conventions. You want to make sure they're not fragile. So, like I mentioned earlier, one of the key aspects of a skill is to make sure you have the domain knowledge to be able to come up with these skills, especially in focus verticals like legal or healthcare or medicine, for example. But this packaging is what makes a skill, and this improves activation accuracy and makes sure that your context window stays efficient. So that's the sales structure. And what I have on the slide are basically three different aspects, like I mentioned earlier. Um, Scripts, for example, where your any recurring and execution patterns, being able to come up with helper functions, executable helper functions. That's pretty important. All of that would go under scripts. And you could have different files within scripts, validate.py or transform.sh, but these are all variable. This is just an example on the right. If you look at the directory structure that I have in the diagrams, that's just specific to a particular example, but you could structure it the way you like. But this is generally a good template to have. As long as you have meaningful file names, the model can look into these folders and understand that it is, looking to, for example, check output structure or a, particular schema, which is why it's called validate.py, right? So as long as the file names make sense, the model is able to figure out what's happening. Um, and scripts basically can package some of those execution patterns and function calls that need to be done. And then references is the other folder where if there's any detailed documentation that you can load conditionally, that's another key aspect that you can have here. When I say documentation, it could mean API notes, it could mean any failure modes based on prior interactions with the API, for example, that we've seen, and any recovery strategies to have. And if there's specific, guidelines around how to structure your output, you could have it in a style guide. So that's how you could structure the references folder. And lastly, the assets folder could include templates and examples and any other static resources that that help structure the whole process around how the final artifact that gets generated, the final output that gets generated, what kind of format would it have to follow. And for example, if you want a skill that can create slides out of an input prompt, you can include some of that information in a slides theme, markdown file, JSON file. So you'll see that in the example here. So this is the layered architecture here, where you could, optionally introduce some of these folders. But I'd say scripts is typically very commonly seen because you want reusable, functions to be called. That is very commonly seen with agents. So, agent skills obviously embody that. And if you've got any references and assets that the skill can be packaged with, then all of this can be put together in the form of this structure. Now, with that, let's talk about triggering and routing and activation. So once you've got your skill description written up as part of the front matter, that's, like I said, primarily the skill, that's the field that a particular agent uses to understand if it needs to activate the skill or not, based on the particular prompt or the user intent that's specified. And once the skill is activated, it basically carries out all of the execution steps that you mentioned within the skill MD file, leveraging all of the other context that's offered, including the, like I mentioned earlier, scripts and references and assets folders, all of the information there. But the idea is that you want to make sure that your skills are executed right and in the right context, and this activation depends on the description quality more than anything else. So make sure you invest in writing a good description. But ultimately, that the progressive disclosure aspect is very important, like I mentioned earlier. So you want to go through discovery, then you want to activate the skill, and only then go over the execution bits from the skill MD file to actually run the particular skill, right? So, the key, thing to keep in mind, the key takeaway here is that for discoverability, all of this depends on, the approximate matching that happens, semantic matching that happens with the description field. It does not depend on a pure lexical keyword match. The model is looking at this description and trying to judge based on its semantic understanding, contextual understanding of whether the skill is relevant or not. It is not looking to do a keyword match. So that's one key takeaway here. And all of this flow basically enables this targeted expertise to be available without that context bloat, which is seen without structuring things in this way with just a pure baseline without skills. And But keep in mind, like I mentioned earlier, a poor description will cause false positives or even missed activations where, aka a false negative, where a skill should have been invoked but is not invoked because the description wasn't as contextual or lacked detail. So this dynamic selection, I think, is pretty important as you structure any kind of specialized agentic workflow. But make sure you invest in coming up with a good description because the success of a system like this depends totally on how detailed that description is and how relevant it is to the task that you're looking to have it run. Now, we talked about some of this already, but this is a synthesis of what makes a good skill, right? So you want to make sure even though there's a lot of flexibility around this and a lot of it is baked into the system prompt of the LLM that you're running, so you could edit that system prompt theoretically and you can make changes to it and have it look at a different structure than just say a skill.md file or a scripts and references and assets folders. You could name it the way you like. But keep in mind, because these models are trained, with attention and have a contextual understanding of the world, it is important to make sure whether it's a file name or a folder name, all of that gives a semantic signal to the model. So the typical recommendation is to stick to this structure as much as possible to make it modular and reusable and focus on gaps that an out of the shelf model, out of the box model cannot reliably handle. So there should be a knowledge gap that you're looking to address. Only then it makes sense to have a skill. Based on your evaluation of the model, you can understand what are some patterns where you see failures, and that would lead to you wanting to create a skill. So make that it should be organic in that sense, where you're trying to address a problem. And the right way to do a skill is to make it focused on a narrow and a repeatable task. And you can have multiple skills that tackle different kinds of narrow tasks. But it's important to make sure the scope is structured well. And the other aspect is to make sure that a skill includes enough detail about the various steps that the model has to perform, the kind of defaults that are needed, if there's any failures or issues at every step, how does it handle edge cases, and what kind of decisions it has to make at every point. All of that has to be specified too. So a lot of the structure and format is absolutely needed, and make sure you reduce the ambiguity when you specify, when you come up with a description, for example. Otherwise, you will see variability across runs where skills, even though they should have been called in certain instances, do not get called, and vice versa. And a lot of this is iterative, as you'd imagine. So this needs refinement through real testing and real world usage. And that's typically how we figure out how to structure a skill in the best manner possible. And this brings us to the evaluation piece where you could carry out an evaluation loop where you understand what the trigger quality of the skill was from just the output quality. So if a skill was triggered, did it lead to the outcome versus was it triggered or not triggered, right? So there's two different dimensions to the evaluation, trigger and output quality. You can also do a baseline comparison with skill versus without skill, where a lot of the information in the skill can be packaged in the same prompt, and then you see if a model is able to respond to it or not. So that can be compared. You can come up with test cases as well, just like test cases in software development at the unit level or system level. And then, if you're seeing a failure, you could group together a bunch of different failures that you're seeing, try to identify the patterns that will tell you what failure modes are being seen across different executions so you can refine the skills accordingly. And all of this makes it an iterative data-driven process, right? So this is how we typically structure evaluating a particular scale. But as you'd imagine, a lot of this does have, good amount of setup overhead. So you need to set up test cases. You need to set up maybe other models as LLMs as judges to serve as a grader and be able to evaluate the whole system, especially if it's open-ended outputs. But this is how we typically structure production systems to ensure that there's reliability and consistency in terms of evaluating an open-ended framework like this. And finally, like I mentioned earlier, I put together a whole bunch of different resources that I personally referenced and to gain a background in this area. So there's some links here, and there's a bunch of more papers and links here too. We are going to be making the slides available after the talk, so you guys will have access to these links. And I've also written a primer that covers a whole bunch of these ideas in detail. So that's available here. And there's a whole bunch of other primers along related aspects, right from an overview of large language models to areas like reinforcement learning, retrieval augmented generation, policy optimization, agentic reinforcement learning, and LLM as a judge or autorator. That's also a key aspect of today's generative AI workflows. So there's detailed primers around, some of these key pieces. And yeah, with that, we're at the end of the talk. I wanted to make sure we have some time for questions. So yeah, with that, I'm happy to take questions.
Alrighty, awesome. Thank you so much, Alan, for the informative, amazing presentation and questions. I I pass the mic. We also have the extensive board, which I will share later for the Canvas work. But any questions? Yes, Kristen.
Um, I was thinking about like how agents and there like could be multi-agent pipelines.
Mhm.
But it's possible for like you can have a planning agent and some of the skills that it has is to be able to kick off other agents. So the planning agent would come down, like decompose the workflow into tasks, and then from there it'd be able to tell, hey, you can kick off these other agents which are listed in the skills. Is that a possibility?
That is absolutely a possibility. And in fact, that is how a whole bunch of production workflows are structured.
Mm-hmm.
So, you could have a planning agent take in user input and figure out what the intent or the ask from the user is. Once it figures that out, it could come up with a detailed step-by-step plan. And like I said, a lot of these steps could either be serial, some of them could be parallel too. So it's a very dynamic dependency graph that gets set up. And based on what subtasks, that need to be executed here, the LLM, that particular planning module, could either send this information back to the main agent, the one that came prior to the planning module, or the planning module itself could spawn a dynamic number of sub-agents at runtime by calling an API. This is typically you spawn an agent, you fork off an agent by calling an API, which is another instance of typically the same model, but with a different prompt. And that prompt again is structured dynamically at runtime based on what the particular agent needs to do per the planner. And you could spawn off a variable number or a dynamic number of agents based on the complexity of the particular task. So say if the task requires parallel web searches, then you could spawn tens of them, right? But say if the task requires making modifications to a file and then having another agent pick up on those modifications and do post processing on that particular file further, then that task is inherently serial, right? Where there is a dependency going from one task subtask to another. So you want to fork off just one agent at that point, make changes to a file, then have that agent get the output back to the planner, and then fork off another agent that does post processing, right? So
Mm-hmm.
based on the task and the complexity, this could be determined at runtime. So,
Mm-hmm.
you figure out how many agents to spawn based on what you're looking to do. So you could have different ranges saying, call an API to run 3 or 5 agents based on this particular task. But if it requires a lot more, then, have 10 agents be spawned. So this is another key aspect of the autonomous decision making capability that makes an LLM an agent. So this is absolutely done in production workflows, which is what makes this very dynamic. So based on the input query, the system figures out how deep and wide it needs to go in terms of the agentic workflow to get the right answer back to the user.
Okay, that makes sense. Cool. Thank you.
Mhm.
Thank you, Kristen, and thank you, Aman.
Mhm.
Any other question? Yes, Mihail.
Hello. And you mentioned about the loading resources conditionally.
Mhm.
And that's very interesting. And you described many reasons why that is important. I was wondering, at what point do we continue loading resources? When do we know when to start loading more resources? I mean, it's kind of like obvious where this is going, but, and the second question would be at any point in time where we're not going to be needing to be sparse with the resources. Can we just upload them all at once at some point where we don't have to, little by little?
Yeah.
Yeah.
That's a great question. So there's a whole lot of there's a big field of research right now that's currently exploring how to do long context understanding for large language models, and this basically is making them better at things like there's this idea in retrieval called needle in a haystack, where you've got a lot of context that's fed into the model, and how does the model identify a small piece of that information that's most relevant to the input query, right? So that's the needle in a haystack problem. And a lot of these models are not great at offering great needle in a haystack performance in different kinds of contexts. In certain contexts they could retrieve the information well, but as soon as you start loading in multimodal data and you start packing up the context fully, the whole context window, you see in some cases that they stop, they aren't able to focus on all of the different parts of context as well, and equally well, right? So this has led to a whole lot of this progressive disclosure, as an idea that's being implemented for skills. As models get better, where you don't have to worry about things like context rot and needle in a haystack performance is excellent, a lot of this might not be needed, but you also have to consider skills are probably they're about like 3 to 4 months old at this point, so it's a newer concept in generative AI. And as people start coming up with more and more skills and context, the amount of content that's part of each skill starts evolving. As you come up with a V0, you start adding more context and start building way more mature skills in a particular agentic workflow. You are including more, filling up the context window more there. You are starting to build more skills. So that growth is also happening in parallel to models getting better. So there's these two opposing forces where you want more skills, but you also want to make sure that the model is able to, retrieve the relevant skills at runtime and not go through context rot, where you filled up the whole context window, loading the entire set of skills that are available along with the execution details. And that will just hamper progress, right? So this dichotomy of ensuring that the description part of the metadata part lives separately, compared to the execution part, is pretty important, and I think that will continue because people are actually using models to write great descriptions of skills and then refining them as humans. And if you go down that route, you are typically able to have models identify what's needed, do great approximate matching, and invoke a skill, which is what's leading to a whole bunch of the success that we're seeing with agentic skills in the first place. So I do think it's a good thing, but as models get better, maybe we wouldn't have to worry about progressive disclosure as much. But that also depends on how many skills are being loaded, and if those people start scaling skills to thousands and millions of skills at runtime, then that becomes a different story. So there's all of these different aspects at play.
Thank you.
Yeah. Hope that gives you some idea of the various pieces that need to be considered as we figure out the next steps and how the evolution of skills will pan out.
Alrighty, awesome. Thank you so much. Any other question? I want to respect your time and finish up right at 5:15 that we promised. Let's see if we have any other questions.
And I'm happy to
Yes,
take some
Pranav.
questions offline as well. If if there's any questions that you guys would like to email me, more than happy to.
I appreciate it.
Mhm.
Hi, I was wondering if the workflow for an agentic system is mostly figured out, do we need a dynamic harness still? Because the way I understand it is a harness would end up deciding what skills you need
Mhm.
in order to perform the workflow.
Mhm.
So a harness needs to be dynamic, but we need to preserve some context. Like we need to preserve some context to make that dynamic harness. So like,
Mhm.
so what are the trade-offs like of between a static harness? So like if we already know the workflows, we could have a bunch of static harnesses that can help us decide the skills. But
Yeah.
so yeah, like what are the trade-offs?
So if you have something that's not going to go through as much of a change or evolution over time, then you might not need some of this packaging, right? Not everything has to be packaged as an agentic skill. Something that's reusable, something that you anticipate will go through changes and evolution where you have new requirements coming in, that is best served with an agentic skill packaging. I can give you a little more details. I can also share some papers that talk about cases where you don't even need multi-agentic flows, and in some cases, multi-agent flows actually hamper performance compared to a single agent system. So there's a whole bunch of research there too. So harnesses need to dynamically decide in some cases whether you need agents or single agent is good enough. Do you even need a skill? So a lot of that determination needs to be done. There's no one size fits all. So,
Okay, that's all.
right. Awesome. I'll have to wrap up here for my next meeting, but
Alrighty, thank you so much. It was an honor having you, and I will follow up with you regarding the pending steps.
for sure. Yeah. Thank you so much, Fatima, and
Thank
great
you.
questions. And feel free to write back if you have any more questions. Happy to answer.
I appreciate it.
All
We know
right.
your busy schedule, so it was
No,
truly an honor.
no, absolutely. Likewise. Thank you so much. Bye bye.
Thank you. Bye bye.